Participants kindly wait for a few more minutes. Let the resource person joins.
Yes, good evening all. Is it am audible?
Ah, yes, sir, you are audible, sir. Sir, am I audible, sir?
Yes, you're audible. You're very much.
Shall we start the session, sir?
Just wait for 5 minutes, yeah.
Ah, sure, sir. Shall we start now, sir?
Yes, yes, you can, please.
I start with the welcome address, sir.
Yeah, all right.
Good evening to everyone. It gives me immense pleasure to welcome you all to the day 3 session of Multi-Domain Faculty Development Program on Interdisciplinary AI-driven innovation and digital transformation across disciplines, organized by the International Indian Society of Research and Development Professionals (ISRDP), a unit of SK Research Group of Companies. We are delighted to witness the enthusiastic participants of academicians, researchers, industry professionals, and students from various disciplines. Their presence reflects the growing interest in understanding how the artificial intelligence and digital technologies are transforming education, research, and society. Today's session is graciously conducted by speaker Dr. Jagdish Pempul sir, Assistant Professor, Department of Information Technology, Saint Vincent Paloti College of Engineering and Technology, Nagpur, Maharashtra. We are honored to have him with us to share his valuable insights and expertise. On behalf of the organizer, coordinators, and management, I extend a warm welcome to all the respected participants and the speaker. Thank you all. Once again, I welcome you all. Welcome, sir.
Okay, thank you so much. Let me clear, my voice is clear as well as screens are visible.
Yes, sir, your voice is clear, sir.
And
Sir, but
is it
in
a
speaking, yes, sir, now it is visible, sir. Screen.
is it visible? Okay, just a bit. Hello.
Yes, sir.
Is it screen is visible and that slides are moving?
Yes,
Just
sir.
check.
It's a moving, sir.
Slides are moving.
Yes, sir. Moving, sir. It's moving.
Okay, all right, all right. Thank you so much. First of all, good evening to one and all present here. Right. I'm First of all, I thanks to Indian Society of Research and Development Professionals (ISRDP) for organizing the FDP on interdisciplinary AI-driven innovations and digital transformation across the discipline. So I welcome everyone for the day 3, and my topic is federated learning with the blockchain integration in healthcare. I Dr. Jagdish Pillai, Assistant Professor at St. Vincent College of Engineering in Nagpur, Maharashtra. As today's topic is very broad, that is federated learning with blockchain. So, as many of the participants are aware about the federated learning as well as the blockchain. Moving towards the presentation, so these are the outline of my presentations. Anyone please be clear? Can you please let me know my voice is clear?
Yes, sir, your
Anyone?
voice is clear, sir.
Okay, all right. So outline of the presentations are going for the introduction first, then we'll see traditional and centralized learning. Then we need to see about what is federated learning. Then history of federated learning, evaluation of federated learning. Then federated learning in healthcare, how we can integrate federated learning in healthcare. After that, federated learning architecture, working of FL in healthcare, types of FL, advantages and challenges with respect to federated learning. After that, we'll going to see blockchain in healthcare, then integration of blockchain in healthcare, then record mining and consensus mechanisms, blockchain enabled federated learning, role of smart contracts, and lastly, we'll see benefits, challenges, and futures research work in the area of federated learning and blockchain in healthcare. Moving towards the introduction. Before starting with the introductions, that we will first clear why we are going to study about the federated learning. What are the different challenges with the traditional approach, right? So before going for federated learning, before learning with the blockchain technology, first of all, I'll let you know what is the drawback of a traditional centralized system or a traditional machine learning system. Now, what happened with the machine learning, or suppose if you want to use AI and machine learning, if you want to train some model, so for training purpose, we require the data always, right? Without data, we cannot train the model, we cannot apply the machine learning algorithm, we cannot generate any sort of results. So data, it is most and foremost things in the machine learning. But when talking about a machine learning technique or any machine learning algorithms that you have been used for training purpose or for developing some sort of a model, so the requirement is, first of all, we required a data sets, we required a data, and on the particular data we're going to apply a particular model, and on the basis of that we'll get the results in the form of graphs, in the form of accuracy, in the form of precisions, in the form of ROC curves and etc. We can find out a confusion matrix as well. But what happened with a traditional system? If you want to train the model, we require the data at our local system, and we are going to perform a training on a local system itself, right? So it means that if I want to work in a collaborative manner, suppose, just take an example, suppose if the data are in a segregated manner, the data are present at a different locations, and I need to perform a suppose I need to perform a learning. If suppose I need to develop a model to train the data which is present at a very different geographical locations. Well, talking about the data is very much crucial. No one are going to share the data with anyone else. The data can be related with your healthcare, data can be related with the retail system, data can be related with the finance system, data can be related with your agriculture or educational systems. We're not going to share the data between us because data are very much crucial, right? So if you're not sharing the data, how the machine learning algorithms works? Because in traditional system, we require the data to train that model because it's a centralized process. We need to train the model in one particular system. We cannot do the collaborative working in a centralized traditional system, in a centralized machine learning systems, machine learning, what we can say, machine learning algorithms. It is very much difficult, right? And if you're concentrating on a one particular data, it is quite difficult to rely on the results which we have getting after processing the model, after applying the model on one particular data set, and whatever results we are getting, it is very difficult to finalize or to see the accuracy of the results whatever we have got, right? To overcome this problem, the concept of federated learning was invented. So talking about the healthcare generates a massive sensitive data. Now today's topic is how we can use a federated learning or a blockchain technology in healthcare system. because federated learning or healthcare, federated learning and blockchain, it is not restricted with healthcare only. We can use FL, we can use blockchain in retail, we can use blockchain and federated learning in fraud news detections or whatever we can say. We can use in finance sector, we can use in education sector, we can use in agriculture sector, right? So there are a lot many applications where we can implement the federated learning along with a blockchain, right? So now today we're talking about the healthcare data, we're talking about healthcare organizations where we can use the federated learning as well as the blockchain. So now talking about the healthcare, it generates a massive sensitive data because the patient data, patient reports, patient prescription, lab reports are very much crucial, that none of the hospitals, none of the healthcare organizations are going to share that data with anybody else. It is very much difficult, or it is very much, it is very much harmful if that data gets shared, because the person's what we can say, the personal information of a particular patient going to be shared with someone else. And if that patient information is very much crucial or very much important for as far as the healthcare organization or the hospitals is concerned, we are not going to share with anyone else. So that's why healthcare, all healthcare organizations, it may be of hospitals, it may be of your medicine industry, it may be of anything else, right? The data is very much sensitive. So AI improves the diagnosis, treatment, and the predictions. If we talked about the AI, artificial intelligence, basically it is used to improve the diagnosis. Because if I want to diagnose one particular patient through a MRI scan, whether that particular patient is suffering with cancer or not, I need to diagnose that things with the help of different MRI images. For that, I need to use an AI to fast process the results, right? So for the diagnosis purpose, for the treatment purpose, for the prediction purpose, we have to use artificial intelligence. Now, traditional centralized system faces a privacy risk because no one is going to share your data for learning purpose. Because if I'm belongs to the A hospital, so for A hospital, the data is restricted to the employee, or we can say the members of hospital A. But if there is a hospital B, so that data is restricted to the B hospital only, right? Now, if we want to share the data between the hospitals, we want to share the data between the healthcare organizations, so they are that is none of the organizations or none of the hospitals are going to share the data, right? Then how to do it? If we are not getting the data, we are not getting the that means, as we already know, if we have a huge amount of data, so that our model get trained very well, that means we get a better accuracy. But if you have a small amount of data, so will not get that much of accuracy. If your model is trained perfectly, you require the more and more data that we already know. That is a concept of machine learning. If you have a little bit amount of data, so your model is not perfect. But if you have a bigger size of data, so definitely if the data size is good, if the data size is more, that means your model get trained, your model get learn a lot from the given data, right? So data plays a very crucial role. So apart from the machine learning, we have to use the concept of federated learning as far as privacy is concerned, because data sharing is there, right? So there is a need for privacy preserving distributed learning. We are working on a distributed learning because we are going to use a federated learning. So in very simple learn, just you can see on the screen there is an image that you can see for training any sort of model. If you want to train any model for any sort of diagnosis or any sort of patient data, so as we already know, we need to use a deep learning model. And what does a deep learning model? In deep learning model, there are three layers. One is the input layer, another one is the output layer, and in between input and output layer, we have a different hidden layers. And we have to adjust the hidden layer, we have to adjust the gradient and the weightage of the hidden layer so that we get the correct output. According to the dataset's value, according to your results, whatever results you want, we need to adjust our DNN, called as deep neural network, right? We have to perform a deep learning, right? Now, if we want to train any sort of model, we require a centralized server where the data is already present, right? So it means that in a traditional approach, in traditional machine learning approach, what we have to do, we have a different machines, we have a client 1, client 2, client 3. These are the different clients are available. Say client 1, client 2, client 3. There are a number of clients and they are having their own data. So client 1 is having the data, client 2 is having the data, client 3 is having the data. So a number of clients are there, that all the data, whatever data is available with the different clients or the different users, that will be gathered together on which the model get work on. That model, that means on the data we have collected, on which we have to perform the models, we have to apply the models. That complete data is given to the models. The model will work on that particular data and it will generate the results. So it means that in traditional approach, what was the client 1 shared the data, client 2 shared the data, client 3 shared the data, client 4 shared the data. It means that every client are going to share the data. But if something happened with the data, it means that suppose data get hacked out, because medical healthcare data are very much crucial. Your retail data are very much crucial. Our finance data are very much crucial. So it is very difficult if in between some introducers or introduces or some particular hackers hack the data. So who will take the responsibility of that? That is a big question mark for the machine learning approach. Wherever we are doing the traditional centralized learning, because all the machines are, all the users are going to share the data, and again that modeling or the training will be happen at a centralized server, right? To overcome this problem, the concept of federated learning was invented. So basically federated learning, or the concept federated learning was invented by the Google, and basically it is used for privacy preserving AI, right? So what does a federated learning? I'll tell you the simple example. I'm not taking any technical example. I'll tell you the simple example. Suppose one puzzle is there, one puzzle is along with you, and that puzzle you shared with your 10 friends, and you have been asked to your friends to solve that puzzle. So every friends are going to solve the puzzles in a notebook, right? Everyone is going to solve the puzzles in notebooks. So once everyone solves the puzzles, so your friends are not going to provide you the notebooks in which they have solved the puzzles. They are just sharing the patterns, they are just sharing the logics of that puzzle. It means that what? You will get a logic at the center. That means you are at the center, you are getting the data from the 10 different peoples. You are not getting the actual data they have solved on the notebooks. It means that what does the federated learning? Federated learning will be worked at their places. That means federated learning will work at a local piece, local systems, right? Local nodes or the local users. That means that means in case of a federated learning, learning happens at a local level, right? Because the data are available with every user as well as every client. So in federated learning, the none of the client, none of the user, they have to share their data to the central process. There is no need, there is no requirement, because data are very much crucial. Because suppose if I asked you, suppose I'm working on a retail or suppose a finance system, and if I'll ask you, please share your credit card transaction history, or suppose I'll ask you, please share me your bank history. Is it possible? Will it be possible to share your history to your close friends? No, not possible, because the data is very much crucial. But orally, when I asked some pattern, that is how much you have spent, how much you have deposited, how much you have withdrawn, that summary that anyone can share, that oral summary that we can say that will be shared by your friends. But when it comes for the data sharing, so none of the person will get share the data. And that too, if you're talking about the healthcare data is very much crucial, that I have cleared very in very first slide. So none of the hospitals are going to share the data, right? So for that, what we have to do, that means we need to do the learning, we have to train the model, right? So anyhow we have to train the model, and without sharing the data. So what we'll do, what does the federated learning said? You have to train the model at your place only. It means that suppose 100 users are there, so 100 users are having their own data sets, so they have to train the model at their own local servers, at their own local system, local nodes, right? And after processing, after applying the model on that data sets which is available with the users, they have to just share, they have to just update the patterns, right? Whatever results they have got, they have to share it with the central system. It means that instead of sharing the data and doing the training at the central level, just we are doing the training at the local level, and at last we will share the results to the central. It means that without sharing the data, just we are sharing the what we can say output of the data set, whatever model we have been applied on the particular data set, right? So it's not, so here the privacy concern is there. It means that there is no need to share a data, just we have to share the results, or we need to share the updated updated, what we can say, updated results whatever we have got at a local level. So FL enables the collaborative model training without sharing the raw data. So none of the users, none of the clients are going to share a data. So after that, only model parameters updates are shared, only the results, only the model parameters are going to shared by your client, or by your users, right? So in short, we can say we don't have to travel a data over the network. We have to travel our model, we have to travel our code, we have to reach our code with the users, or we have to reach out our code with a nodes only. That means without sharing a data, just we have to share our model, we have to share our codes with the particular user. They have to work on that and share the results only. That is the federated learning, that is the working of federated learning. That means we have to work collaboratively, we have to train the model in a collaborative fashion, and at last we get the results at a central process, that's at a server, at one place we'll get the results. That is the working of federated learning. Now, what is the history of federated learning? Federated learning was officially introduced by the researcher of Google in 2016. Basically, it was invented in 2009, but it was came into the picture in 2016. That Google team, Google researcher, that is it is MNC, that Google companies, Google researchers, they have found, they have invented the federated learning concept. So the very first paper, that is the first paper, was published by the Google team. That the topic was communication efficient learning of deep network from the decentralized data. Whether different authors and the Google team were involved for this particular paper for inventing the federated learning. That is, one of this Jakub, another one is Brandon, Daniel, and the Google other researchers as well also involved for preparing this particular paper, and making this federated learning in making the federated learning for the working purpose. Now, why Google developed the FL? Why federated learning was developed by Google? The reason is Google needed a privacy preservation solution, right? One well-known example that Google have in nowadays in every phone, that everyone are going to use the mobile phones, right? So whenever we do a chit chat, or whenever we are going to use a WhatsApp, and you are trying to type a message, just I'll type happy, HAPPY, happy. Immediately, the suggestions come: happy birthday, happy anniversary, happy day. So you'll get the different suggestions, right? So Google have used a federated learning for implementing the federated learning for suggestion on mobile keyboards. That means your mobile itself predict what type of keyboards the user wants, so it will give a suggestion, it will give the corrections as well, right? So it means that the very first time the federated learning was implemented in a keyboard actually. So it is used for smart suggestions, it is used for personalized AI services. That means the user don't want to write down a complete statement, that is, for example, happy birthday, stay blazed. So I don't have to write down a complete statement. Once I write happy, I space B, so it is automatical, it is automatic, that words suggest by AI, that is birthday, right? If I'll press B for blazed, so it is already come blazed, right? So it means that the suggestions will come from the AI through the keyboards. It means that the learning happen, right? For such kinds of learning, the Google has used a federated learning concept for a very first time in mobile keyboard predictions for giving the different smart suggestions with the AI based. Now, instead of collecting the user data centrally, device trained models locally and shared only. Now, what happened with the mobile phones, right? If I'll train the mobile, or I'll train my mobile on my data only, so I will be limited with the specific words only. But what happens? Suppose if there are 100 people are using the mobile phones, 100 people are using the WhatsApp, 100 people are using the messagings, right? So every people are using the different words, different synonyms, different kinds of statement. Everyone is using, right? So whatever words, whatever statements you are using, that
updated words or whatever statement, whatever words you're using, data gets stored into the central server or getting stored into the server, so that that words will be available, that words will be accessible to all the mobile users. That means there is no need that if I'm not aware about a blaze word, I haven't used blaze word, so blaze word never comes in your mobile phones. But if you use a federated learning, if someone else person use blazed word, it means that that blazed word is also accessible to you as well, right? So that is the work of federated learning. Even though you are doing the training at your mobile phones, doing the work on your mobile phones, doing the work on your nodes or machines, but the updated result gets stored or get accessible to the central server through the federated learning, and that is the work of federated learning. So actually this reduces the privacy risks and the communication cost, because I'm not going to share my own data, I'm just sharing the updated one, I'm just sharing the pattern to my central system. Now, what are the FL evaluations? In 2016, the federated learning formally introduced by Google. In 2017, FL using Google Gboard keyboard predictions that I have already explained you. In 2017, that in for the keyboard predictions and suggestions that Google have used the FL. In 2018, research expanded to a healthcare and IoT. In 2029, in 2019, integration with blockchain and Edge AI started. Obviously, I will tell you about the blockchain in further slides as well. In 2020, massive interest during the COVID-19 healthcare analytics. As we know that during the 19 to 22, right? So we all are struggling with the COVID. So basically in 2020, they have heavily used federated learning for the mass COVID-19 analytics. In 21 to 23, FL applied in smart hospitals, finance, and the cyber security. In 2024 onwards, FL combined with blockchain, explainable AI, agents, and edge computing. So this is actually the evaluations from 2006 to 2024 onwards, that all the organizations, those who are dealing with the very crucial and important data, they are moving towards FL and blockchains. Now, federated learning in healthcare. Why we need to use federated learning in healthcare? Right? Healthcare becomes one of the most important federated learning application domain. The reason is medical data is highly sensitive. If we talk about the hospital, the patient names, patient medical history, patient lab reports, their prescription, their biometric data, their insurance details, all of these things are very important. And none of the medical organization, none of the healthcare organization are going to share this data. Because if you are going to share these data according to the act, according to the regulations of HIPAA, that is Health Insurance Portability and Accountability Act by United States, as well as GDPR, that is General Data Protection Regulation European, that is European Union, that is EU. So these are the HIPAA and GDPR are not going to allow you to share all of this data with anybody else. Even though you are running your own hospital, so you are not going to share the patient history, you're not going to share the patient data with anybody else. According to the act, right, you will be punished if you share the data. So you are not going to share the data. If we are not going to share the data and we want to do the learning, we have to do the automation in case of healthcare industry, in case of hospitals, right? It may be, for example, if I want to work on I want to work on predictions of cancer level. I want to work on, suppose, any sort of data, any sort of diagnosis, any, say, suppose liver failure, we can say, that is what we can say, that is that there are n number of diagnoses are there, right? We have to work on different heart attacks data. We have to work on different cardiac arrest data. We do different records, different datas are available, and I need to work on that. But if the data is not there, how we can work on the data to speed up the medical functionality or medical operations? It is very difficult, right? So what we have to do, that every hospital, every medical is having its own data. They have to keep their data at their place only. They don't have to share. But what we have to do, we have to develop a model. We have to develop a global model, and that model, that code, we need to share with the industry, or we can say medical hospitals, or we can say healthcare
organizations, and that model will be applied on the data which is available at a local place, right? So it means that the hospital don't want to share a data. They are just applying our model, whatever we have designed. They have applied our model on the data which is available with the hospitals. So it means that the data is there with only. They are not going to share data. They are going to share only the resultant pattern. They are going to share the resultant updated model to us. It means that it will very much helpful to predict, to diagnosis the different diseases, or different diseases, or we can say whatever things we need to work on. So it is very easy to work collaboratively without sharing the data. Then hospital cannot freely share the patient record. Yes, obviously none of the hospital will be going to share the data. After that, as I already told you, HIPAA and GDPR are not going to share a data. So they are, according to the Act of United States and European Union, they are not going to allow you to share the data, right? Now, what is the architecture of FL? Just see in the diagram, which is shown in the screen actually. So we have a different FL client. Just you can see there is a client 1, client 2, client 3. There are n number of clients. So n number of clients, it is also called as n number of users. And that user itself called as federated learning clients, federated learning users. On the left hand side, on the right hand side, you can say there are different federated learning clients, right? And your left hand side, there is a FL server called as federated learning server. That means there is a central server. So what we are going to do, how actually federated learning works. It means that suppose if there is a client 1 is having his own data. Client 2 is having own data, client 3 is having own data, up to client n is having own data. Now I need to develop one machine learning model. And these clients are not going to share their data with a server or with the central server. But I need to develop a model, I need to predict something. So what I'll do, I'll use a federated learning, right? What I'll do, I'll develop a global model. I'll develop one model called as a global model. I will share that model with the FL client, right? Because FL client are having the data. So whatever model I have prepared, I have shared with the clients. That model, the client will apply the model which I have shared with the client on their data. And after that, they will get the results. It means that whatever results they have got, is indicated with a blue line, right? So it means that initially model updates given to the clients, model will work on that. That means every model, sorry, every client will get the results, and that suppose client 1 get the results, gets that model get updated, and again that model get submitted to the FL server. Client 2 apply the model on their data. Again the model get updated, again they'll get the results, again that model gets stored, model gets shared with the FL server. Again client 3, client 4, up to the client, and will do the same process. It means that every client have applied our model on their data, and that model get updated. So once the model updated, that model gets submitted to the FL server. That is federated learning server. Now what does the federated learning server, what it will do? It will collect the updated model from all the clients, and the aggregations it will aggregate, that it will again update the model called as global model. Then again global model is given to the client. That again a global model is given to the client 1, client 2, client 3, and client n. Again that client will work, that client will apply our model on the data sets. Again they'll get the results, again submit to the FL server. So it means that this is an iterative process. That means that every client situated at a different location, located at a different locations, everyone are working separately, everyone will get the result, different result, and that result get stored into the FL server called as centralized server. So it means that instead of relying on a one particular model which is work on a one particular data, federated learning provide this different kinds of data which is available with the different kinds of clients, which is available with the different kinds of users. So obviously we have a huge amount of data collected from the different sources, collected from the to the different clients or the users, it means that the model get updated, aggregated in such a way that you will get the accuracy, you will get the predictions at the highest level, right? So likewise your federated learning work. So it means that every time we need to provide a local model to the FL client will apply that model on the data sets, then again it will send the results, send the pattern to the FL server, and FL server will again update the global, it prepare a aggregative new global model, and again it will send to the clients. So that is a iterative process we need to do. So here none of the clients are going to share that it is very much clear, clients are not going to share any data with the FL server. Clients are just sharing the updated model which I have provided the model to the clients. Please keep these things in mind. So that is the architecture of federated learning. Now what is the working of federated learning? First of all, we have to initialize the global model. We need to prepare a global model, because we are going to provide this model to our different clients located at a different geolocations or different areas, right? After that second step, send the model to the hospital or the clients, that we are working on a medical healthcare. So there are n number of hospitals, so we need to share my model. We have to share my model whatever I have developed which are different hospitals or a different clients. Then what the clients or the hospital will do, hospital or clients will train the locally on a private data, because every hospital is having their own data. So every hospital or a client, they are going to apply our model which we have provided as a global model to the client. So client will apply that model on their own data which is available in their hospital or which is available with the clients, right? So it means that local learning, right? So it is trained local on the private data. Then share the gradient and the weight. As we know, if we use a deep neural network or any neural network, so if we want a desired output, we need to set the weighting. We need to we need to see, we need to work on the gradients also, right? So once you got the results, once you got the outputs, just output gets shared with the FL server. We're not going to share the data, right? So once the training or the once the learning done properly, the gradient or weightage or we can say updated model are going to share with the FL server. Then aggregate updates into a global model. Again, we have received the updated model from all the clients. Again, we need to aggregate the things, and again we have to develop a new model, right? So this is actually a iterative process. We need to follow these steps while using the federated. So how federated learning used in health? Now see the diagram. There are a number of hospitals. There is a hospital A, hospital B, hospital C. There are a number of hospitals are there, and there is a global model. So what we do? We'll share our global model, right, with a hospitals. Now what hospital will do? Hospital will apply this model, whatever we have provided, on their own local data, on their own data sets, and they will get the results. And once they will get the results, that result gets shared with the global model. So likewise at hospital 1, hospital 2, hospital 3, all the hospitals are going to apply the model on their own data. They will get the results, they will get the gradients or the weightage value, they will get the results, they will get some sort of a patterns, and that patterns will get submitted to the server. Then again global model get updated, right? So it means that you can think the number of hospital increases, so learning get increases, number of data sets get increases, and we'll get a variety of results, we'll get the accuracy of results very high. Predictions very much clear, predictions are very much high, right? Very much clear or very much correct, we can say. So that is the use of FL, federated learning, for what we can say, for learning through the different collaborative manner, or we can say learning the collaborative things, or we are going to apply the we need to collaborate with different hospitals or different clinicals or health organizations for training the data. So likewise we will use FL in healthcare. After what are the different types of FL? So if we talked about the federated learning, so it is divided into three parts: horizontal learning, vertical learning, and transferred learning. We'll go one by one. So basically horizontal learning is based on distribution of data by similar devices. Apply the providers will not overlap with the same data. There is no overlapping at all. Second one is vertical learning. User sets are all the same. User sets are same, but there are different types of user data. User data may be different. Transferred learning, it is limited in number of identical users, very small data sets with the identical features. Basically, transferred learning is used when the data sets is very small. At a time, you'll use this transferred learning. I'll explain each and every one. The very first thing is horizontal federated learning. So basically, what it means is horizontal federated learning. If we talked about the horizontal federated learning, it is basically a sample-based federated learning, right? The meaning is hospital collect the similar medical attributes, but their patients are different. Just consider an example. There are multiple hospitals. Suppose hospitals located in Bangalore, hospital in Chennai, hospital in Nagpur, hospital in Pune, Mumbai, located at different locations. But considering the common data, suppose the common data means the name of the patient, age of the patient, gender of the patients, blood group of the patients, right? That that common parameters that every hospitals are going to collect. So it means that in horizontal federated learning, the patients are different. That means users are different, but sharing the common data. It means that hospital A is having the patient data, patient name, patient age, patient gender, after that weight, height, and blood groups, and etc. And again, the patient 2 is hospital 2 is also taking the same data. Hospital 3 also taking the same data. So when we collect the same kind of data from the different hospital and learning happened, right? If training happens on such a kind of data called as horizontal federated learning, it means that hospital may different, but in every hospital, the patient data, whatever patient data are collecting, that patient data are same. That means even though patients are different, but the attributes are same. That means the horizontal federated learning. After that, the next one is vertical federated learning. In case of a vertical federated learning, that it means feature-based federated learning. That means the meaning is organization have a same or overlapping with users, but a different types of features or a data. Just consider there are hospitals, there are some insurance companies, there are some medical histories of the patients, right? It means that if one particular patient is there, the one particular patient is having the medical history, same particular patient is having the claim history, same particular patient is having some financial history, some particular that same patient is having the insurance history. It means that the patient is one, but that patient is connected with the different resources, different companies, or what we can say different kinds of data. Like is that patient is connected with claim, patient is connected with the finance, patient is connected with the insurance, patient is connected with the lab history, like on or we can suppose one particular patient is suffering with some sort of diseases. It means that again the areas are different, but the patients are same. It means that the different types of feature data, because patients are same, but that patients are related with the different kinds of data, different kinds of features. It means that both may refer to the same patient users, but each organization wants a different information about them. It means that if I am a patient, I'm having a patient history, I'm having my own medical history, again I'm having my own claim, I'm having some financial history, I'm having some educational history. It means that I'm connected with a different organizations, right, called as vertical federated learning. It means that even though the person is same, but connected with a different organization or different kinds of data or different kinds of features. The use cases are personalized healthcare. For fraud detections, we can use these things, because if you want to detect a fraud, so while detecting the fraud, right, or whether we are, suppose if you want to find out the person whether he is criminal or not, so find out the person is criminal or not, so we need to connect with the different things. We don't have to think that particular person has done this particular crime only, so it means that it is a criminal, but we need to check all the related history, right? So it means that such kind of situations we can use a vertical federated learning. So we can use vertical federated learning in fraud detections, personalized healthcare insurance analytics. So one more example I'll tell you. Suppose if I'm having a bank history, and other side if I'm having a suppose e-commerce history. So these two things are interrelevant, because I am having a bank history and I am having a e history also. That means
what we can say, we have a e-commerce history. So according to the e-commerce history, that if I'll get the e-commerce history data,
So the bank will find out if the particular person is spending this amount, or suppose that particular person is spending the amount in lakhs. So they will offer you the loans. They will call you and they will offer you the different kinds of loans, right? So they are interconnected. Even though the persons are same, but it is connected with the different kinds of organizations or different kinds of system. It is interrelevant with the data, right? So that means a vertical federated learning. After that, transfer federated learning, basically it is used when the data size is very low. So if the data size is very small, so as we know, if we use a machine learning things, if the data sets are very small, so our model will not get trained, and as well as we will not get the accurate results. That means our accuracy is very low, right? So when data size is very small, so we have to use a transfer federated learning. Just take an example. Suppose the hospital situated in a rural site. In village, the hospital is there, but there is a large research center, right? So in rural hospital, suppose if one village is there, around 50 people or say 100 people are residing in that particular villages, and I need to do the predictions on the data sets or the data which is available with the rural hospital. But obviously, because it is a village or a rural hospital, so data sets is very very small. So in such a kinds of situations, how I can do the learning, how I can train the models? So I'll take the help of other hospitals, I'll take the help of other organizations which are having the similar kind of data in a large amount, right? So say for example, the hospital situated in Bangalore or Pune or in Mumbai, in urban areas. So in urban areas, a lot many people are accessing the same hospitals. So they are having the huge amount of data. They are having the large amount of data. So we can use that data for a rural hospital data. What you can say, for the rural hospital data learning purpose, or rural hospital data training purpose, we will use the other hospitals data for the training kind of purposes. So it means that transfer federated learning is used when the data size is very small. So in this particular case, we'll take the help of the other resources. So applications are rare disease predictions and small healthcare institutions. The institutions or the small healthcare institution or the hospitals are very small, but obviously data is very small. So we need to take the help of other hospitals as well. So that means a transfer federated learning. Now, what are the advantages of federated learning? We have to preserve the patient privacy. That means we are not going to share any patient data. We are not going to share any images. We are not going to share any lab reports. We are just applying the model which is provided by the FL server. We have to apply the model on the data, generate the results, generate the accuracy, and that updated patterns will get shared to the servers. It reduces the data transfer. We're not going to transfer a data to any machines or to anyone else. The data is already there with the local machines or the local servers only. Supports the multi-hospital collaborations. We are collaborating with the multiple hospitals, because otherwise in traditional system what happens, if I have my own data, so I have to train my model on my own data. But if we'll have a multi-hospital collaborations, if you have we are going to collect data from we are going to we are going to apply our model on a different kinds of hospitals, on a different kinds of data. So definitely the accuracy of the results will get increased. Our model get trained very well. After that, enhance the predictive accuracy with the distributed data and complies with the healthcare regulations. Now, what are the different challenges in federated learning? Right? Now, data heterogeneity, that means if you're talking about the different hospitals, so different hospitals are collecting the patient data in a different formats. It means that in some hospitals, they will ask some, suppose hospital A is there, they will ask the patient name, patient weight, then gender, then after that their blood groups and all. But some of the hospitals are not taking all of these details, right? So heterogeneity means that different hospitals are having the different formats of collecting the data. So this is one of the challenge, because when we integrate a federated learning in healthcare, so we need to keep in our mind that the data, it should be common format. That means every hospital use a common format for collecting the data. And communication overhead,
right? That means we need to collaborate with the different hospitals, so communication is very much important. That means no one is going to trust on you, because when you approach to someone else, some hospitals, I'm implementing this such a kind of model, or I'm going to create such sort of systems. So it is very difficult to generate the faith, that generate the what we can say, we need to build that much of faith between while doing the collaborations. Then model poisoning attacks. So it may be possible the data may be hacked, but it means model poisoning attacks, that maybe some can think, some person, some hospitals can think that yes, you are asking for, or what we can say, that means you are not the correct one. That means you are just spoiling the data, you are asking for spoiling the data and other things as well. Then lack of trust among the participant, that participants are going not going to trust very easily. That means you need to build a trust. And single point aggregations vulnerability, because every model get trained at a local site and data gets shared, or the updated model gets shared with the server, centralized server. So aggregation vulnerability may be happened. Now how the blockchain come into the picture? Now we have learned about the federated learning. Now see the blockchain. If you're talking about a blockchain, it is one of the secure technology nowadays. Every major industries are using. It may be of healthcare, it may be of retail, it may be of finance, it may be of the agriculture. So everywhere nowadays blockchain are using, right? So blockchain, it is basically, it is more and more secure technology, right? So if you want to store, if you want to preserve the privacy of your data, you have to work, or you have to change your system, you have to integrate the blockchain concepts, right? So blockchain can be implemented with IoT devices. Blockchain can be used with different kinds of what we can say systems. While building any sort of model, you can use the blockchain technology for privacy purpose. So why we are going to use a blockchain? Sorry. So why we are going to use a blockchain? Because blockchain provide a different sort of, just a sec. Hello, is it visible? Sorry for the interruption. Hello, is it I'm audible? Anyone please update me? Hello, is it audible? Hello, anyone please update me, is it I'm audible? Is it I'm audible? Anyone please update? Hello, hello, is it audible? Anyone please update?
Yes, sir.
Okay, all right. Thank you. Thanks for the confirmation. And see, my screen is also visible, na? Please update me. Screen is visible.
Yes, sir. Visible.
Okay, thank you so much. Now, why we are going to move towards the blockchain while integrating in healthcare, or while we are going to use a blockchain in different industry like finance, retail, or agriculture? Blockchain provides some sort of features like data security and integrity. That records are stored in tamper-proof blocks. Once it is entered, no authorized modification is possible. So we have to use a blockchain for security purpose, because whenever we are going to store the data into the blockchain, once you enter the data in the blockchain, so we are not going to update the data, because it is a tamper-proof. Once data recorded into the blockchain, so it is add, or it is stored permanently. We are not going to edit any sort of data. It is decentralization. It means that there is no centralization, there is no control on a central system. It is decentralized. It means that everything or every data is available in a decentralized manner, in a form of blocks, and every block is connected to each other. So it means that we don't have to worry about the centralized system, or we don't have to worry about our record or a data. That means if something happened with a center server or a cloud, so it means that data may be hacked or data will be used by someone else. So this would not be happened with the blockchain. Then transparency is with the privacy. It means that if you want to store the data through the blockchain, so everything is known to everyone. We have to use, suppose we are going to use a public blockchain. So in case of a blockchain, so whatever you are doing, so the things are very well known to everyone, which is the part of the block. That means whosoever may be the part of this blockchain, right? So it means that the transparencies with the privacy, then interoperability, that blockchain enables the seamless record sharing across the different hospitals and the clinics. Patient-centric ownership, that means patient-controlled, who can access their data via smart contracts. It promotes the trust and reduces the misuse of health information and auditability. Every access or update permanently record. So while using a blockchain, there are n number of features. That's why the people are using the blockchain in technologies nowadays. Now, why to integrate a blockchain with FL? Right? So in case of a federated learning, what happens? We have to train the data at a local site and we'll get the update at a central server, right? But if something happened with the central server, right? So your complete model get collapsed down. So for that, what we have to do, we will use the blockchain concept. It means that if there is a federated learning, model get trained at the local site, updation gets shared with the central process, and that updation on a central process, it means that if we integrate the blockchain, so it means that there is no central server. So the replica of the particular copy or the replica of the transaction is available with the different nodes or the users which are available or which are the part of the system actually. So when we integrate the blockchain with FL, blockchain removes the centralized dependency. There is no centralized dependency, but to ensure the integrity of model updates. That means if the model get updated, we'll get the ensures. That means your data will not be shared with anyone else. Your data will be your data will be saved securely. That means everything happens safe, right? Then it provides secure participant authentication, improves the trust and auditability. That means in blockchain, if you are using blockchain, so if once the data or transaction get recorded, no one are going to who edit or update the records. And support the decentralized healthcare ecosystem. There is no centralized, so it supports the decentralized ecosystem. Then purpose of record mining, if we are using a blockchain, so there is a process of record mining. That means blockchain uses a peer-to-peer network, right? That means there is a mining process. It means that suppose if I want to do any sort of transactions, right? Suppose I want to store the patient data in the blockchain. So what I'll do, that particular data get floated all over the network. That particular network, the miners or validators are exist. They will mine the data. They will find out the transaction. That means they will mine the transactions, or validated transaction means they are going to find out whether it is genuine, whether we are getting the data from the authenticated or authorized person or not. If data get mined successfully, then and then that data get recorded into the blockchain, right? And for mining and validation purpose, we'll use a POW and POS called as proof of work and a proof of stack for mining and validating the data. Now, what is the consensus mechanisms? We're using a blockchain technology. We have to use a proof of work and a proof of stack. So basically, these are the consensus mechanism to validate or to mine the data. So proof of work means what? In case of a blockchain, there are different types of consensus mechanism. Not only these two, we have a proof of work, proof of stack, proof of burn, proof of activity, so right, proof of elapsed time. There are different consensus mechanisms that we can use in blockchain, right? I'll explain about these two, that POW and POS. So proof of work, when the Bitcoin blockchain was invented, so at that time the people were used the POW called as proof of work. But when Ethereum blockchain came into the picture, so proof of stack, that is the consensus mechanisms used in Ethereum blockchain, right? Now, what is the difference between POW and POS? So in case of a proof of work, what happened? Whenever you want to perform a transaction, right? So that transaction, or if whenever you initiate a transaction, that transaction get available with every peers. So it means that every peers are whatever peers are exist or the miners are exist in the blockchain, so that data is reached to every peers. And in case of POW, that whatever transaction get mined, that mine the person who are going to mine the transaction called as miner. But in case of a Ethereum blockchain, in POS, proof of stake, will that miners is called as validator. This there is a nomenclature that we can use miners in proof of work, validators in proof of stake. The work is same for both POW and POS, right? So what happens in POW, that all the miners will start working to mine the transactions. So it means that all miners work simultaneously. So definitely the high energy consumption requires, right? And we require the powerful mining hardware as well. If we want to do the POW, so we require to that miners required to solve the complex mathematical puzzle, and it is very difficult to solve this complex mathematical puzzles because it requires a complex hardware as well and requires a huge amount of energy consumption as well, right? So in POW, what happen, that transaction reaches to every peers if the peers who mine the transactions, who validate the transactions, it means that that miners will get some sort of a reward point. But in case of a proof of stake, what happened? In proof of stake, we have to prepare a stack where the validators put their own cryptocurrencies for validating the transactions, right? So if any validator take a risk, if any validator thinks I need to validate the transactions, it means that the validator who spend the high amount of cryptocurrency on the POS stack, that particular validator will get a chance to validate the transactions. If he will validate the transactions properly, it means that he will get a reward point. Otherwise, the cryptocurrencies is that particular validator put it in a stack that will be used. That will be what we can say lapsed out, right? The POS key points are very POS is very efficient, energy efficient, because only one person has to do the validation, not all. In POW, all the miners are doing the validations or mining, but in case of POS, only one person has to do the validation. Now, how to use a blockchain technology? How blockchain technology works? We need to initiate a transaction first, then we need to prepare a block, then block send to the network, and network will mine the transactions. If mined properly, then block get added to the blockchain. So likewise, we have to the blockchain will be formed, right? Now, what is the structure of blockchain? In case of a blockchain, so blockchain is a chain of blocks. So you can see in the image there are number of blocks. There is a block 1, block 2, block 3. Number of blocks are there, and every block contains the hash value, contains the hash key values of the previous one. Right? Suppose the block 2 is there. Block 2 contains the hash value of block 1. Block 3 contains the hash value of block 2. So every block contains the hash value of previous block. So what happened with the block 1? Block 1 is not having the previous block. So block 1, block 1 always called as a genesis block. So the very first block of a blockchain is called as a genesis block because block 1 is not having the previous block. So what happened in blockchain? If any hackers try to hack the particular data, so every block is connected to each other. That means every block is connected with the previous one. So if any hackers introduce trying to hack or breach out some sort of data, all hash value get affected. So we can easily identify that particular on the particular data the introduce, or we can say the hack, what we can say, the hacking, or we can say that a particular person has attempted the hacking. That means that the person has trying to breach out the data, that we need to identify very easily. And when we store the data, so that collection of transactions, you can see in the lower side, that collection of transaction which is always uses the tree, right? So in case of a blockchain, we have to use a Merkle tree, right? So transactions always recorded in the form of Merkle tree. So this is actually the structure of blockchain. Now, what is the architecture of blockchain enabled? Federated learning. So healthcare institutions act as an FL client. So whatever hospitals are there, suppose if you want to use a blockchain, and we have to integrate blockchain and FL for healthcare system. So we have to here hospitals are the FL client, right? And blockchain records model updates securely. It means that when FL clients apply the model, updations generated, that we need to update the model, and updated model gets stored into the blockchain in a decentralized pattern. Then smart contracts out automate validations and rewards. Then global model aggregations become a transparent. Then distributed ledgers improve the accountability. So these are the different things which we need to concentrate. Then blockchain enabled FL, you can see in this diagram, there are number of hospitals are connected here. So number of hospitals are called as FL client in a global model, which is called that global model, or the model aggregations happens in a blockchain that will distributed manner. You can say in a global model there are peer-to-peer network is there, that you can see it is highlighted in the blue color, right, in the global model in the center. So that means there is no central process, right? So global model stored in a decentralized pattern. That means we have to use a blockchain. So other that learning, or we can say what training will be happen at the local site. That you can see there is a hospital 1, hospital 2, hospital 3, hospital 4. So learning will be, that training will be happen at the local site. And once the updated model that once the model updated, that will be shared with the blockchain. In blockchain it will be validated, that particular transaction or the model. Once it is validated, then and then that model or whatever patterns we have received from the FL client will be recorded into the blockchain, so that the privacy get increased, so that the privacy get preserved highly by using the blockchain enabled FL. Then what is the role of smart contracts? It automates the participant registration. That means basically smart contract, it is using blockchain. Basically smart contract, it isn't even an agreement between the person and the systems actually. So there is no manual things required to validate or to authenticate the transaction or authenticate the data. So there is an automated process. So we have to use a smart contract in blockchain. So we have to automate the participant registration, validate the local model submission. That means whenever the FL client will provide the updated model, so we have to store it into the local model through the blockchain. It manages the incentive and the penalties if the training or the model applied applied very well, or you will get a very good results. So definitely you'll get some sort of incentives, or if something happens, you will be penalized also. And ensure the secure collaborations among the hospitals. So but obviously we are using FL, so we require the collaborations as well, right? So after that, security benefits. So protections against the data tampering, because we are using blockchain, so no one will breach out your data. Improve the resistance to malicious update. None of the hackers will going to attempt the hacking, or none of the person, or the no one AI hackers going to hack your data. Traceability of model contributions and secure sharing without exposing the patient record, because we are not going to share any patient record with anyone else, so the data is very much secure. Then healthcare applications, we can use FL and blockchain based model for disease predictions and diagnosis. For cancer predictions, we can use using medical image processing, we can use the same system. For COVID-19 collaborative analytics, we can use personalized treatment recommendation and remote patient monitoring. That is one of the most applications of FL and blockchain integrations with healthcare, because we can monitor the patients and remotely. If suppose the patient is residing at the Nagpur and the doctor is there in US, so through this particular system we can monitor the patients through the remote access. Benefits of blockchain FL in healthcare. So multiple hospital collaboratively train a cancer predictions model. Patient data remains local. We're not going to share a data. Blockchain stored a verified update. That means whatever data we want to store into blockchain, it is verified. Global model achieves a better accuracy while preserving the policy. So, but obviously we are using a collaborative model. We are preparing a collaborative model. It means that we'll get a better accuracy. Our result will get very much high and accurate and correct. What are the various challenges of blockchain enabled FL? Scalability issues, that means managing number of users. If the number of users are more, so it is very much challenging to manage all of these things. Then high computational cost is required, because every model is trained at a local place, so high computational cost is required. Latency due to the consensus protocol. And energy consumptions in blockchain, if you are using a blockchain, so energy consumption requires because we need to use the consensus mechanisms. Then complex implementations in healthcare, so the implementation is complex. It means that we are where we are integrating blockchain and FL, federated learning. So for implementing this, for integration, for doing the integration of this, so that is a complex model actually. Then what is the future research directions? We can develop a lightweight blockchain framework, AI driven smart contracts we can develop. We can use edge computing while integrating the FL and the blockchain. We can use the quantum resistant security. We can use explainable AI in healthcare FL systems. So these are the different and future research directions on this particular area. The researcher can work on it. So all of this from my side. So I hope I have cleared with FL and blockchain idea, how FL and blockchain integrate with the healthcare organizations, right? So with this, thank you all. If any sort of questions, so please let me know. Any question, please let me know. I'm very happy to answer your questions.
Participants, if you have any queries, you may ask now.
Yes, organizer, I'll request you please take a screenshots and please share with me, na? Just take a 2 to 3 screenshot and share with me of my PPTs.
Sure, sir. I'll share you, sir.
Just take a screenshot of PPTs as well.
Yes, sir. Okay.
Just you can take it and please share with me. Just take a screenshot, sir. Done. Yes, sir. Have you taken the screenshots?
Yes, sir. I'm taking the.
Okay, just check.
Yes, sir. Yes, sir. Any other frame, sir?
Yes, any questions, participants?
Shall we conclude the session, sir?
Yes, yes, you can. If there is no question, then you can conclude.
Yes, sir. Okay, sir. Good evening to everyone. As we come to the end of today's session, I consider it as a great privilege to propose the vote of thanks. First and foremost, I express our heartfelt gratitude to our esteemed speaker, Dr. Jagdish Pemple sir, for delivering such a insightful and informative session. Your valuable thoughts, practical perspective, and expertise have greatly benefited all the participants, sir. We sincerely thank you for spending your precious time with us. I extend my sincere appreciation to the Indian Society of Research and Development Professional (ISRDP) and SK Research Group of Companies for organizing this wonderful faculty development program and providing a platform for interdisciplinary learning and collaboration. I also thank all the coordinators, organizing committee members, technical support team, and volunteers who have made dedicated efforts to ensure the smoothness of this session. A special note of thanks goes to all the participants for their active presence. Once again, thank you all. Let us meet in the day 4 session tomorrow. Thank you. Thank you, sir.
Thank you so much. Thank you so much, SKRG's Academy, for organizing such a beautiful faculty development programs. Right. So I thanks each and every participants for their patient listenings. Thank you all.
Yes, sir.